Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. In order to see the differences between different methods of punctual estimation, we are going to apply other methodology to the same function that we used in the previous exercise. So we are going to use the maximum likelihood methodology in order to obtain a theta estimator for the function theta plus 1 multiplied by x power to theta. In order to build the maximum likelihood function, we have to compute the multiplicatory of each of the elements that we have in our sample to the function. In that case, it's a density function. It could be a discrete random variable, so we should have to apply to a discrete or to a mass probability function. So in that case, we apply our function to the first point of our sample, x sub 1. So theta plus 1 multiplied by x sub 1 power to theta, multiplying to the function applied to the second point, theta plus 1 multiplying x sub 2 power to theta, and so on till the last point that we have in our sample. If we summarize all this information, we reach that we have theta plus 1 power to n multiplying by the multiplicatory of 1 from I equal to 1 to n of x of y power to theta. In order to obtain the maximum, we should have to derivate the function with respect theta. But in order to do this in an easier way, we know that the log transformation of the function gives us the maximum over the axis in the same point. So we will apply natural logs to the function, so we will have a natural log of a multiplicatory, so a sum of the natural logs. So in that case, we have the natural log of the first part of the expression, theta plus 1 power to n, plus the natural log of the second part of the expression, that is the multiplicatory of y equal to 1 to n of x of y power to theta. So if we download the exponentials from the expressions, we shall have n multiplying the natural log of theta plus 1 plus the summatory of the natural logs of x of y power to theta. Another time we can download the power of x of y, so the final result is that n multiplies natural log of theta plus 1 plus theta multiplying the summatory of the natural log of x of y. The third part is to derivate this expression with respect to the parameter of interest. As we have only one parameter, we will have only one derivate. If we have more than one parameter, we should have to build a system equations with each of the partial derivatives of the expression with respect each of the different parameters. So in that case, we have only one parameter, theta, so we have to derivate only with respect to theta. The result is equal to n multiplying the quotient of 1 divided by theta plus 1 plus the summatory of the natural log of x of y, and we equalize this expression to 0. So the following step is only to isolate the estimator. In that case, we have n equal to minus theta multiplying the sum of the natural log of x of y less the summatory of the natural log of f sub y. So if you arrange this expression, you will reach to the final expression of our estimator by the maximum likelihood method, that this is equal to minus n minus the sum of the natural log of x of y divided by the sum of the natural log of x of y. You can rearrange that, and the final solution is that we have a quotient with minus n divided by the sum of the natural log of x of y minus 1. But this is not enough from the mathematical point of view, so we should have to check doing a second derivative of this first one if this second derivative is negative. In this case, we can affirm that is a maximum. So the following step is to do the second derivative with respect to the parameter. So if we do the second derivative with respect to the parameter, so we have that is minus n multiplied by 1 divided by theta plus 1 to the square. So this is going to be always negative, so we can affirm that this is going to be a maximum.